Hello everyone, welcome to a new series I'm doing where we use AI to tackle mathematical coding challenges. So hopefully it'll be quite interesting, if you like this sort of thing of course. So on HackerRank, which is a website I quite like which does automated coding challenges, they have the Project Euler problems. And Project Euler is a set of currently 254 programming challenges which all have some kind of mathematical ideas behind them. So, for example, the most recent one is sums of the digit factorials, whatever that means, or prime subset sums. So it's all kind of mathematical ideas which are exploring with coding. And I think the idea is that there's meant to be some kind of cascade learning effect, whereby solving each problem you learn a little piece of technique, either in coding or in mathematics, that then helps you solve later problems. And HackerRank I quite like because it allows you to check your answers automatically. It will tell you whether you've done it correctly or not. And so we'll start with Project Euler number 1, which is multiples of 3 and 5. So let's read the problem. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6 and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below n. Okay. So it's going to give us these problems. So it's going to give us t problems, and we have to sum the numbers up to n. So for instance, in this sample, it's giving us 2 problems, and we have to sum the numbers up to 10 and the ones up to 100, and the output it's expecting is 23 for the first one, that's for 10, and 2,318, and that's for 100. And so there's one bit of subtlety to this problem, which is that what happens to multiples of 15? So if you have multiples of 3, if you go through and add all the multiples of 3 and then add all the multiples of 5, you'll double count all the multiples of 15. So you have to be a little bit careful about that, and the problem statement doesn't give that away, because below 10 there aren't any multiples of 15, so it doesn't kind of come up in that example. So that's the kind of subtlety to it. And so how we're going to approach this is I'm going to copy the problem statement, and I have access to OpenAI's Codex, which is a recently released auto-completion tool for code. And so you can put in some amount of text, whether it's comments or code, and then ask the AI to present some continuation of that code such that it does what you want it to do. And I tried the OpenAI Codex programming challenge the other day, and it was quite effective. And I thought these Project Euler problems might be an interesting sandbox to kind of test out whether we can get the AI to solve these problems and how much help it needs to do it in a good way. So first, let's put some triple comments in. Apparently that's a good way of telling it that we are using Python. It likes to have triple comments, and apparently it works slightly better than pound signs. That was in the documentation, so we'll try that. Find the sum of all the multiples of 3 or 5 below n. Okay, so that's the problem statement. That will kind of, so the way the AI works is it reads through, and so this will kind of prime it with this is the thing that we want it to do. And then let's take the code that it's given us as a little template. And all this is saying is use Python 3, import system, and then t is the first line, that's how many problems we've got, and then iterate through each of these, grab the n that we have to add up to, and then what? You know, that's the problem, is we have to solve that. Okay, so let's see what it does. Okay. So it's done it for us, and this is pretty impressive. So it says start with a sum of 0, and then iterate through from 1 to n, and if it's a multiple of 3, this is I modulo 3, or it's a multiple of 5, then add it to the sum, and then print the sum, which is the result. So let's go back here and present that as our answer. Run code. Okay, so congratulations, you have passed sample test case 0. So for these 2 examples, it gave the right answer. And let's submit the code to see how well it's going to work. And so one of the things that's going to happen next is it's important to look at the size of the inputs. So for t, the number of test cases, there can be up to 10 to the 5, which I think is 100,000 test cases, so that's a lot. And for n, it can go up to 10 to the 9, which is up to 1 billion. So the largest thing, it could ask you to add all of these multiples up to 1 billion, and that's a very large, that's a large number in this context. So for these 2 test cases, 2 and 3, this timed out, it was too slow, because we iterated through all of the things. So if we did it up to 1 billion, we'd have to go from 0 to 1 billion and run that loop 1 billion times to add these numbers together. And the way you go faster than this is you need to observe that If I told you to add all the multiples of 3 up to 99, say, that's the same as saying 3 times the sum of the numbers 1 to 33, right? Because the multiples of 3 up to 99 are 3, 6, 9, 12, and so forth. And that's 3 times 1 plus 2 plus 3 plus 4 plus 5 plus 6. But if you want to add the numbers up to n, there's a very famous formula for it of n plus 1 over 2. And it's actually a formula that's attributed to Gauss that one day when he was in school, it's like an apocryphal story, I don't know if it's true, the teacher wanted to keep the students busy and he said, oh, just add the numbers up to 100 or add the numbers up to 1,000 or something, you know, a very similar problem to this. And all the students grumbled and took out their chalkboards and started working at it. But Gauss sort of very quickly looked at the problem and came up with this formula where you could add the sum of numbers up to n very quickly. And the essential way of solving that problem is to notice that if you're adding the numbers up to 100, if you add 1 plus 99, that's 100. And if you add 2 plus 98, that's 100. And if you add 3 plus 97, that's 100. So you sort of, if you start going up from the bottom and down from the top, you can pair the numbers off so you get the same thing. So you get n over 2 lots of n. So I'm getting 50 lots of 100. And that, I think it's like that. Yeah, something like that. And then that, I think I've got it slightly wrong there, but basically it's like that. You sort of make a rectangle out of it, and you get this thing of n plus 1 over 2. So let's see if the AI can do that for us. So let's say, rather than solving it like this, find the sum of multiples in order 1 without iterating through all the numbers. So we don't want to do it by iterating, we want to do it by something else. And we want the computer to work out what that is. So let's run it. Okay, and there we go. So it's using this n plus 1 formula. So it's saying basically n minus 1, and then it's doing the 3 times, and then n over 2, but it's kind of got some 3's and 5's in it. It's quite a complicated formula. I would struggle to write that and understand exactly what it's doing. But one thing that's important to notice is that it's got this idea that you need to get the multiples of 3's and then get the multiples of 5's, but then also remove the multiples of 15 because you can double count them. So let's put this back in here. Okay, and let's see how that works, because that's order 1. So it's going to do it with a formula in 1 step. And let's submit the code. And we did it! Success! Congratulations, you've solved this challenge. Okay, so that was challenge number 1. And I think the OpenAI Codex did amazingly. It was able to comprehend the problem properly, and it came up with an iterative solution on the first go. And then when we added this small amount of explanation for why, which helped it do it faster, it came up with the fast solution, which is a simple formula, which seems to work. So yeah, congratulations OpenAI. So that's problem number 1. I hope you enjoyed this first video and that it was interesting. And hopefully we'll carry on and make some more and tackle some of the future problems. Alright, thanks for watching. Alright, goodbye.